Hi, today I'll be talking about hydrocarbons. So a hydrocarbon is basically an organic compound which contains only hydrogen and carbon. And some of the simplest hydrocarbons are methane and ethane. And so methane is basically one carbon and four hydrogens, and it basically has a shape of this. And these are some of the simplest hydrocarbons that you can make. So there's one type of hydrocarbon that is prevalent, and that's called an alkane. So an alkane is basically a hydrocarbon where there are only single covalent bonds. And these carbon atoms can be put in a straight chain, or it can be put in a chain with different branches. And so a straight chain alkane is basically shown right above with, I'll move this one sec, with this. And so the alkanes, they can have a molecular formula and they have a complete structural formula, a condensed structural formula, a skeleton formula, and a line angle formula. And this is the molecular formula. This is the complete structural formula. This is the condensed ones. And this is a skeleton formula with just carbons. And this is the line angle formula, which is like bare bones, like basic. And you see like the line angle formulas a lot in organic chemistry, which makes organic chemistry kind of hard. And I got slapped in the face with that today. So let's go on. So you also have branched chain alkanes, and these alkanes are basically not always bonded in straight lines. And so you have a substitutionate, or sorry, I botched the name, substituent. And that's basically the group of atoms that take the place of a carbon atom in a hydrocarbon. And this is called an alkyl group, or an alkene with the hydrogen removed. And so you have three alkyl groups: the methyl group with the CH3, then the line denoting a bond, the ethyl group with a CH3 and a CH2, then a bond, and the propyl group, a CH3, a CH2, and another CH2. And so basically, this just gives you how to name an alkane, and how you do it is that you first just find the longest chain or the parent structure, and then you have to number the carbon atoms in the chain. You then add numbers to the substituting groups to identify its position, and then use prefixes to indicate the appearance of the same group. And some common prefixes are di, tri, tetra, penta, hexa, hepta, and octa. And octa is 8, not 9. That's, yeah, sorry for the bad quality assurance. So this is 8, not 9. Disregard this. This is right. And so this hydrocarbon, so this has two methyl groups, which is basically a CH3 and a CH3. And so it has two of these groups, right? And so that will basically be called a dimethyl. And so then you have to use proper punctuation when writing. And so basically what you have to do is you have to just show the group. So what you have over here is you have to first find the longest chain, which is over here, CH3, you know, all of this. And then you have to number the carbons in the chain, which is from 1 to 7. And then use the numbers to identify its position, and use the prefixes to indicate the appearance of the same group. And so there's one ethyl group over here. So this is 4 ethyl, and then ethyl, and then you add another comma. Then you do, as there's 2 and 3 methyl, there's 2 methyl groups at 3 and 2. Then you just do 2, 3 dimethyl. And so you also see this longest chain. So this is like the parent structure. And so there's 7, so it's hepta. So it'll be heptane, dimethyl heptane. So this will basically be a simple problem, and there's a lot of more harder problems, and I wish I could help a lot more by this is like a recent topic which I learned. So I don't have much in terms of more practice problems. So yeah. So you also have like the properties of alkanes. So the thing is that molecules of hydrocarbons such as alkanes are nonpolar molecules. And so these nonpolar molecules have weak attractions between the other particles, and so they can break up easily and they can break their attractions easily, which changes their state from a liquid to a vapor. So yeah, and this is like the all of the condensed structural formulas of all the alkanes that are like the most important ones. So yeah. And it just has ane, and so you can just see that like it's CH4, C2, C3, C4, C5, C6, C7, C8, C9, C10. And so that's just done by using meth, eth, pro, but, pent, hex, hep, oct, non, dec. So you just have to use all of these, and then when you have it. So 22.2, unsaturated hydrocarbons. So you have alkenes, which are basically hydrocarbons that contain one or more carbon-carbon double bonds. And the simplest of these is alkene. So alkene basically has, so it has C, H, H. So it has this, right? And so you have a double bond between the carbon. So you have like the octet rule in effect. My bad, I made a mistake with that. Eraser. So you have the octet rule in effect. So you basically then add just two more hydrogens. So H, H. So it'll be C2H6. And you also have alkenes, which are basically hydrocarbons that contain one or more carbon-carbon triple bonds. And the simplest one of this is C2H2. So you have the triple bond between the carbons, and then you have a hydrogen, and you have a hydrogen. So it'll be C2H2 with an octet rule in effect. And all of these are basically aliphatic hydrocarbons. And so that's the naming of this. And so one way to remember it is, so you can say it as A as single bond, E as double bond, and Y as triple bond. So like if you need to know what's the difference between alkane, alkene, alkyne, it just do alkane is single, so A is single, E is double, Y is triple. So I would try to use that to remember it, at least for the basics. So 22.3, isomers. So isomers are basically when you have the same molecular formula in an organic compound, but you have different molecular structures. So one example of an isomer is basically between butane and 2-methyl propane, and they have different structures. And so this is basically a structural isomer where you have compounds that have the same molecular formula, but then the atoms are joined together in a different order. So you have a lot of versions of those, and I'm not sure if the people I made this for need to know all the different types, but yeah. And so with these structural isomers, they differ in boiling and melting points due to having different areas where the bonds are in. And so this basically also gives them different chemical reactivities since the intermolecular attractions are different, and it doesn't bond with all of these are non-polar, but then they have different ways of bonding and all of that. So 22.4, hydrocarbon rings. So you have cyclic hydrocarbons, which basically is when hydrocarbon compounds have the carbon chain in the form of a ring. And this is shown over here in this diagram with a triangle, a square, a pentagon, and a hexagon having methyl groups. And so an aromatic hydrocarbon basically contains a benzene ring or a compound like a benzene ring. And so the thing is, benzene is the simplest compound in this group. And with benzene, the bonding electrons are shared evenly around the ring, with basically electrons being able to have a resonance structure, meaning that you can have the double bonds either between these two hydrogens or these two hydrogens. The double bonds can be anywhere, so it's all of them have the same strength. And so this also is called an arene. So you also have a substituted aromatic compound where you have substituents added to the benzene ring. And this is shown over here, where you basically added CH2 and CH3. I believe that's an ethyl group. Yeah, I think that's an ethyl group. So you have an ethyl group added straight to the benzene. And so you can add as much of those as you need because there's a hydrogen over here, and that's basically substituted for the carbon instead. So, yeah. And 2.2.5, hydrocarbons from Earth's crust. And this is the last section. So you basically have three types of hydrocarbons from Earth's crust: natural gas, petroleum, and coal. So natural gas is basically like the main fossil fuels, and these are basically methane, ethane, butane, and propane. And when these are combusted, they create water, carbon dioxide, and heat, always. And these are very simple molecules. So petroleum. So petroleum is a much more complex molecule. You have the petroleum as like C20H40, or like I'm just putting in numbers, but they're extremely large. And so petroleum is basically refined by using distillation. And so what you do is you just heat the petroleum into fractions in order to remove things out of the way. So you can heat the petroleum to remove gasoline. You could then do it to remove kerosene and heat it up to 150 degrees. And then you could then convert it to fuel oil by heating it to 225 degrees. And then lubricating oil at 400 degrees, and just go so on and so forth. So you just use heating in order to separate the smaller hydrocarbons and make it into simpler molecules that you can use more efficiently rather than having the petroleum. And so by doing this, you basically use catalysts and heat in order to break these bonds. And lastly, we have coal, which is basically classified by hardness and carbon content. And coal is basically found in underground and surface mines, and they consist of condensed aromatic compounds with a very high molar mass. Coal also can contain other minerals such as sulfur, which burns and can create air pollutants such as sulfur dioxide and sulfur trioxide. And you can create many products with coal, such as coal tar, coke, gas, and ammonia. And coke is basically used as a fuel in industrial processes and is used in refining iron ore. And it's not coke the drink or whatever else you might think of it. There's so much slang. And you also have coal tar, which basically is used. I believe it's used in roads and construction. And you also have gas, which used for cars and other things. And lastly, you have ammonia, which is a good gas. So I guess that's pretty much it. That's all I have. So I hope this helped with studying for any test or any assignment you have. And I hope you all stay safe.